Problem 21, page 684. We have a negative charge 1 equal 1 Q1, we can say Q1 equal minus 2.5 microcoulomb, and we have a positive charge Q2 has 6 microcoulomb. The question is, determine the point where the electric field is 0. Before solving this problem, let's discuss a little. If we have here the negative 1, and here we have the positive charge, and so here it's negative and here it's positive. Here and here it's impossible to have a zero electric field for a simple reason. Let's take, for example, this position. At this point, the charge 1 will create E1 in this direction because it's negative. So the field must be inward. This one is positive, so the field must be out. Okay, must be out. So here we have E1 and here we have E2. The resultant field must be in this direction, so it's impossible to be 0. The same for this region, you get a field, so it's impossible to have a 0 field. The only region it's on the x-axis. Okay, we have to say maybe here, maybe here, maybe here, to the right, between, and to the left. Let's see every one. At this position, here the charge 1 will create a field. It's negative, so it must be in, toward the charge. 2 is positive, so it must be out. So here in this case, we can have two opposite fields. So it is possible to have a 0 field. The same to the left side. At this point, the charge 1 creates a field E1, it's in towards the negative, and the positive will create in the opposite direction. So we get two opposite field. So it may be possible to have a 0 field to the left and to the right. But between, if I take any point here, the negative charge will create a field towards the negative 1. The positive charge will create a field out. So we can say out. So E1 and E2, here we have E1 and E2 have the same direction. So it's impossible to have a 0 field in the location between 1 and 2. Now, by this discussion, we precise the location to the left or to the right. Now, let's go to solve the problem. I will choose any location to the left or to right. So let's take here a point. Here we can say charge 1 and 2. The charge 1 will create a field in this direction, the blue one, because it's negative, so we have E1. And the red positive charge will create a field out because it's positive. So here we have a field like this, E2. These are in the opposite direction. Let's precise the distance of this point. We can say it's at a distance equal, we can say here it's at a distance equal d from the charge 1 equal d. And here we have a distance equal 1 meter, equal 1 meter. So the total distance between here and here equal d plus 1 meter. Let's write the equation. So this is a point P. The total field at the point P equal E1 plus E2. You see well, we don't have Y components, just X components. Equal E1X plus 0 Y component plus E2Y, excuse me, E2X plus 0 Y component equal E1X, E1X as absolute value times the direction. E1X, it's in the positive I direction plus I plus E2X, it's in the negative I direction. So it's equal to minus E2XI. So E1X, E1X as magnitude equal E1 because it's equal E1 cosine 0 equal E1. And you know well that E equal K E times Q. We are talking about Q1. Q equal minus 2.5 times 10 power minus 6. Don't forget its absolute value. Divided by the distance square, the distance between P and 1 equal D, divided by D square. The same for E2x equal E2 cosine 0 equal E2 equal K Coulomb constant times Q2 equals 6 times 10 minus 6 Coulomb divided by the distance between P and 2 equal D plus 1. D plus 1 square. It's okay now. We can substitute these two values here and here. EP equal E1x equal K E minus 2.5 times 10 minus 6 over D square in the direction of I, in I direction, minus E2x equal K E 6 times 10 minus 6 divided by d plus 1 square j. The condition what? This field must be equal to 0. So equal to 0. Excuse me. It's I. Here it's I. It's I. So the condition is must be equal to 0. We can add these two values. Equal the okay, here we can see well we can write equal, we can do the projection in terms of x-axis, so we do the projection in function of x prime. So we can write here ke minus 2.5 times 10 minus 6 over d square equal to the other side equal ke 6 times 10 minus 6 over d plus 1 square. We can cancel ke, we can cancel minus 10 power minus 6. Finally, d 6 d square equal minus 2, no, equal plus the absolute value equal 2.5 d square plus 1 plus 2d. You can calculate this equation by calculator. You get the final answer is 1 d equal 1.8 1.82 meter, and this is d1, and d2 equal minus 0.3 meter. You see well here you have a negative value and a positive value. So here we got d1 equal 1.82 meter and d2 equal minus 0.392 meter. We have a negative value, excuse me, we have a positive value and a negative value. Let's analyze this results about the region. We know before that this is an acceptable region. We can have zero electric field here. Here it's not acceptable. So if D is positive, you will get, we have the origin here, you will get 1 plus a positive value. So here it's okay. If D is negative, so we will have 1 minus 0.392. So it will be in this region. This region it's prohibited. We cannot, it's not acceptable. You cannot be here. So this is the accepted value and this is rejected. Thank you.